Okay, so we're going to move now into what I think you're going to find to be an absolutely fascinating presentation. It's by a professor in the Center for Cognitive Neuroscience at Duke, and is actually a research scientist here at the MedStar National Rehabilitation Network. And he's going to talk about TSA officers, athletes, video gamers, studying visual memory in novices and experts. Welcome to the MIT stage, Steve Mitroff.
Thanks. Thank you, Mark. It's been a really fun day with all sorts of fantastic talks. And one topic that's been touched upon a lot, but not a whole lot explicitly, is the concept of visual memory. And we've talked about it in a few different ways of the different types of memory. And what I mainly want to focus on today is this concept of visual memory. And what I mean by that is the relationship between what you're perceiving and what you're storing. So you can think about the knowledge that you have and how you see the world. And there's this really nice interplay between what you know and what you see. As you gain new information in life and you receive information through vision, it's dramatically impacted by your prior knowledge and what you already know. So how you already know things will influence how you take in new information. And vice versa, how you are understanding things and holding information in mind is highly dependent on how you see it. Now, we obviously have lots of senses, and we've talked about them throughout the day. So I talked about smelling spaghetti, and we have different types of memory that you can think about. But as humans, one of the main senses we have is vision. And that's what I mainly want to focus on today. And what I want to do is try to make 3 points throughout the course of this talk. The first is to make the claim that visual memory is a key cognitive process, and that it underlies many aspects of life, and very much so for the healthcare profession. I want to show you some examples of how it can vary across people, so that some people are better able to make use of their visual memory than others, and that it's malleable, and that it can be enhanced and boosted in different ways. And we've seen examples of that, talking about the different types of memory that the memory athletes use. And if it's something that varies and it's something that's malleable, then it really kind of opens the door to be something really cool, something that can be used and taken advantage of to boost performance. It can be used for rehab or all sorts of different environments where if you are starting to lose and things aren't going great, it's something that's plastic. It can be changed and boosted. So the topic I want to use to make these examples is the idea of visual search. And there's a lot of different types of visual searches that take place in the healthcare profession across the MedStar system. Looking at radiographs and radiology, ultrasounds, EKG readings. If you think about all the different types of ways that people are trying to find a target, trying to find something that is the goal of the profession is to find something, find that abnormality. And for a radiologist to look at a radiograph, a mammogram, and try to find something that's wrong, it's very much involves memory. First, they have to remember what it is that they're looking for. What is an abnormality? They have to kind of go back to the med school, think about what the images are. There's a lot of different types, and they have to remember them. There's another aspect of memory that doesn't always sort of come to mind right away, and I want to touch on that in just a second by using a much simpler sort of type of memory, the idea of where's Waldo, right? So there's a different type of visual search, something that people pay money to do, right? You buy these books and you spend time either with your kids or by yourself and trying to find Waldo. For those of you who are ignoring me, I'll show you where Waldo is. He's right there. So to find Waldo, this is a visual search, right? And there's many aspects of visual search. I like to study this topic because it touches on so many different parts of cognition. So it involves perception. You have to see. You have to see what is the target. If you can't perceive the color red, you're going to suck at finding Waldo, right? So you have to be able to see. So that's the first. Second is attention. You have to know where you're putting those perceptual abilities. You need to move around that image and put those efforts at different spots to try to find Waldo. Decision making is huge, especially for doctors. You're looking at an EKG reading, you see something that may or may not be abnormal, you focus on it, you stare at it, and you make a decision. And a huge number of medical errors come about from making the wrong decision. So decision making is a huge component of visual search and something that we could test. And then for today, memory. So memory is a huge aspect of visual search. And we've already talked about one, you have to know what you're looking for. If you don't know what your targets are, you're in trouble. Right? So you have this, and here your target is easy, it's Waldo. You don't have to remember. Once you've seen him once or twice, you kind of got it. But if you're looking for a much more complex set of possible targets, memory is really important. You have to remember a variety of different aspects. The other aspect of memory that's not quite as obvious is you have to remember where you've already looked. So if you're trying to look through the scene and you stop on an item and you're trying to make a decision, if you don't know where you've looked, you're in trouble. And you can think about this in two types of search. So we have consistent and inconsistent search. And if using these blue circles as sort of a cartoon of where your eyes are and where you're looking, on the left is what we'll call consistent search, on the right is inconsistent. And what you see is that consistent searcher used a nice zigzag pattern. They go back and forth and try to find that item. Now, if that person stops on an item, studies it, tries to make the decision, is this a target or not, and they decide, no, it's not, I'm going to keep going, it's easy. They just keep going on their zigzag path that they've been doing. But if you're the inconsistent searcher and you stop on an item and you stare at it and you're like, okay, it's not an abnormality, let me keep going, right? Like where have I looked, where have I not looked? And when we look at a variety of different types of searchers, from radiologists and TSA officers and participants at Duke, what we find is the consistent searchers are better. They're more accurate, they know what they're doing, they perform much, much better. And the inconsistent searchers, they go back and they look where they've already looked, and they make all sorts of mistakes, and they perform worse and they're slower. So what I want to argue is that what this consistent search does is it frees up some of your visual memory resources. If you think about perception, attention, decision-making, and visual memory, they all tap into a limited pool of your resources, that you have this small set and you're trying to make use of it. And if you are a consistent searcher, you free up that visual memory component and allow you to put more energy into the perception, into the decision-making, and it results in you performing better. So what I want to argue, I've told you I want to make 3 points. One is that visual memory is a key cognitive process. Second, that it varies across people. And third, that can be enhanced. So hopefully I've started to give you at least a hint that it's important. I think it is, but hopefully you guys think so too. So now I want to give you some examples about how it varies across people. So I'm a psychology professor, and we work with a lot of different groups, and we try to understand how people differ. And at the individual level, at the group level, and all sorts of different aspects. And so one thing that we can look at in trying to understand how performance varies across people is to look at expertise, so professional versus non-professional performers. And we could also look at how abilities change by your everyday activities and pastimes. So we've tested radiologists and orthodontists and athletes and baggage screeners, but the most data we have is from baggage screeners, so I'm going to tell you about that. We actually, for those of you who are radiologists, so we started testing about the same time as TSA officers and radiologists. You would think it would be really hard to get TSA officers. I've tested 400 of them, and at the same time I got 8 radiologists. So for those of you who are radiologists, I shake my fist at you for not doing my study. So the data, what I want to talk about is data that we got from TSA officers and from Duke participants. And we've also tested age match controls that don't paint their faces. And we gave them all the same simple visual search test, so we could assess performance and look at how they perform. Are they consistent, inconsistent? How accurate are they? And look at a number of different different factors. And what we found was the TSA officers were more accurate and they were slower. So that's odd. Colette talked about how as the students were gaining expertise, they got faster and faster. And typically what you find is that experts are quicker. They perform more quickly. But what we found here, that the TSA officers actually slowed down. They were more diligent. They took more time. They realized that if I want to be more accurate, I need to take the time and do this right. What we found was that these benefits, at least in part, were driven by being more consistent. They were consistent searchers. And it was highly related to their accuracy. So those who were really consistent were much more accurate than those who were not. And overall, the TSA officers were more consistent than the undergrads. So we found similar results with radiologists as well. And this starts to give us some hints as to how people might differ and what this might mean about sort of freeing up those visual memory resources so that they could perform their task. Another way to look at the differences across people is to look at activities that people engage in. And one thing that people have looked at a lot is effects of action video game playing, finding that those who engage in this activity perform better across a wide variety of cognitive tasks. And other labs, including mine, have looked at visual search and also visual memory with video game playing. And what we found, very similar to us, our TSA officers, was that the gamers were better searchers. And they had heightened visual sensitivity. With less information, they were able to make their decisions. And again, we found that this was at least part driven by having better search strategies. They chose to engage in the search in a more effective way that made it simpler for them and freed up resources, freed up that visual memory so that they could perform the task better. So one question you may be asking is, the chicken or the egg problem here, right? So which came first? Are gamers better at these cognitive tasks because they play games? Or do they play the games because they already had these enhanced abilities? Right? So it's a very important question about causality and how this comes about. It's also a very difficult question, and it's hard to test. And so I want to talk about two general paths that people can take to look at and that we've been exploring. The first is to track learning over time. And this is tough, right? It's really hard if you imagine if you want to track are certain doctors better at one task than another. So do you have to go back to med school to start tracking performance? But do you have to go before med school? It's really hard to understand how you could build up these experiences. My lab has gotten access to a really nice tool that allows us to ask some of these questions in a new way that sort of takes advantage of the big data aspect of life. And so there's this game called Airport Scanner that I was lucky enough to just sort of find while randomly playing on my phone. And in this game, you are a baggage screener. You see these items go by, and it's on Apple and Android, so you can download it now if you want. So you search, and I'll show you an example in a second. And your job is to find targets. And so here's sort of a video of what this is actual gameplay. So you pick a day, and you load the day, and you'll notice that main center part is your visual search. And these bags go by, you control it with your finger, and you could swipe faster and slower, and then you tap with your finger on the illegal items. You have to track the people online. You see that green circle in the upper right. That's a clock, so some levels have a high speed demand, others don't. So you can see there's a variety of different items, and there's actually a couple hundred of the illegal items and a couple hundred of the legal items. And if you're talking about memory, this is memory, right? So you have to learn several hundred different things that are prohibited, and you have to tap on them. And if you don't tap, you lose points, and you may lose the game. You start with only a few, and they keep getting added to your memory set as you go. So I found this game, and I was like, wow, this is kind of awesome. This really fits with my research program. Reached out to the company. We formed a partnership. They started saving data. They weren't saving any. They made all the data available to me for research. We now have data from over 7 million users, and we have about 2 billion trials of data. And 2 billion trials of data is a lot. We get about 1 or 2 million trials a day. So it's this really fantastic resource for us. And what we could do with it is we could look at a number of different questions. And one thing that we've started to do in terms of learning is look at how you build up information over time. And so we could look at a given player for the first time they see an item, to the second time, third time, fourth time, so on. And we could do this for thousands of players at the same time. Potential solution for the chicken and the egg problem is to train. You take individuals who are not at that heightened performance, and you see if you can make them there. And this is something that nicely fits with the third point I wanted to emphasize today, is that visual memory can be enhanced and can be boosted. And we've been doing this over the last several years, trying out a variety of different ways that we might be able to alter and enhance performance. My lab's partnered with Nike and now a company called Snaptech to make use of a athletic training tool. And it's these eyewear, they're called the Nike Strobes. When Snaptech releases them soon, they'll have a different name. But the idea is to use eyewear where the lenses flicker. So you can see in this little video, the lenses are alternating between transparent and opaque. And you wear them while you train. So you don't try to wear them while you perform because you'll be bad, but you wear them while you're warming up or training. It's analogous to putting weights on a baseball bat for warm-up swings, putting weights on your ankles when you go swimming. Take the weights off, the bat's lighter. You could swim faster. The question is, can you do this for vision and attention? Nike had developed it, elite athletes swore by it, but nothing was known. And so we got our hands on them, got a grant to try to understand, do they work, and then really to get at the underlying mechanisms of what might happen. I think that one's awesome for physical therapy and occupational therapy, for strengthening core muscles. It's taking something that people already do, but putting these eyewear on them. And there's a lot of cool things that could be done. So we've looked at a number of different questions. We have 4 papers so far from this work. The last one was working with the Carolina Hurricanes, showing on-ice performance enhancements for those who used it. But the question is, what are the mechanisms? And for today, this one is probably the most relevant, is that we were able to find changes to memory, to visual memory. So if you think about, if you're trying to play catch and you're only getting glimpses of the visual world, you're trying to get your hand to the right spot, you see that ball coming towards you, you're going to try to hold more information in mind, and then be there. So you're trying to extrapolate by holding more information in mind, which means increasing the capacity of your visual memory, trying to boost performance so that you can perform normally while in that degraded environment. Take the strobes off, and you still experience that boost. Okay, so hopefully I've convinced you that visual memory is an important process, that it does vary, and since it can be enhanced, this might be a really nice tool for being able to boost performance. Thank you. Sure.
Do you have some time for a couple of questions from Steve? Questions, anyone?
Yeah. Yeah, so the question is there an optimal frequency for the strobes? So the product that we had 8 different levels, and we would stick, what we do is get people at where it's hard for them, and then when they get better at that, increase the difficulty. When they get better at that, increase the difficulty. It's still lots of open questions about what is right, and are certain levels right for some activities versus others, but what we always try to do is keep people right at that point of performing at a difficult level. Great. Thank you.
Thank you, Steve.